Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Error question number 268. Missing number. Given an array nums containing n distinct number in the range of 0, n. That's the important note. Return the only number in the range that is missing from the array. Fine. So let us see the example. Here, the first example is 301, right? So here they have given the range as what? 0, n, where n is the length of the array. So it is at range of 0, 3. So in between 0, 3, there are 0, 1, 2, and 3. So between this, what are the values missing? 2 alone missing. So we want to return 2. Here it is like 0, 2. So 0, 1, 2 is the values, and 2 is missing. So 2 will be my answer. Fine. Now here I have 0, 0 to 9 values, and 8 is missing. So 8 is my answer. How to find it? Okay. The first approach that comes into our mind is brute force approach, right? Simple brute force approach. How the brute force approach works? See here. First of all, let us take this first example with more values. 3, 4, 5, 0, 1. So let us take this is our array. Now I will like what is the length of this array? 5. So obviously the range is between 0 to 5. Can I say like this? Yes. So this is the range. Okay. So what are the values in between them? 0, 1, 2, 3, 4, 5. So these are the values. Now I'm going to check whether this 0 present in this array. Yes, it is present. Okay. I check this 0. Now 1. Yes. Now 2. No, 2 is not present. So break and return what? 2. Hope you understand. Right? So this is my first approach. What is the time constant space empty for this approach? I can say, so I want to traverse for this n numbers, and for this each number, I again traverse for this n times this array. Right? So it is like O of n into n is equal to O of n square. And space empty is O of 1. Okay. So this is my time and space empty. Can we optimize it? Okay. The second approach is, can we like, if I have in order, like see here 0, 1, 3, 4, 5. Suddenly you can say 2 is missing. How? 0 next 1, next 2 should be there, but no 2. So can I sort it? Okay. Can I sort it? If I sort, this is my order, and I am going to check whether 1 plus 1, sorry, 0 plus 1 is 2, yes. Now 1 plus 1 is 3, no. Then what is missing? 2 is missing. So just return 2. Can I understand this? So this is sorting method. Okay. Here I use what? Merge sort to optimize my time complexity. Now, what is my time complexity? I can say my time complexity will gonna be my like O of n log n. Yes. And what is my space complexity? My space complexity will be O of n in merge sort. Okay. So this is my second time and space complexity. Fine. Now, whether we can still optimize it, because see here n log n, and space also. So can we still optimize it? Okay, let us see. See here, this is like, uh, I'm sure like it is in range, right? So if there is a 5 range, okay, 0 to 5 range, I can say this 0, 1, 2, 3, 4, and 5. Let me take an array. Now, see here, if I have 0, I will make this as 1. If I have 1, I will make this as 1. Initially, these all are zeros. Okay. Now, I'm going to check whether, see here, this is my array, right? First of all, it is 3. So take 3 and make this as 1. Now again, 4. Take 4 and make this as 1. Now 5. Take 5 and make this as 1. Now 0. Take 0 and make this as 1. Now 1. Make this as 1. Now, at last, which value that have 0 should be my answer? Can I understand this? Yes. So, this is the third approach. What is the time velocity and space velocity for this approach? I can say my time velocity will gonna be like O of n, because I'm just traversing the array and selecting the index in the another array and making this as what? 1, 1, 1, like that. Okay, what is the space? It is O of n. Okay. So it is still optimized in this. Okay. Can we still further optimize? That's a challenge, right? Because see here, it takes what? Space. Time is okay, this linear time. Still, we can optimize anything in time complexity and also space complexity. Okay, we can check. Okay, the fourth approach is that we want to optimize it, right? How can we optimize it? Fine. Let's take what will be the range if I have this 0 to 3, 0, 1, 2, 3. This is gonna be my range, right? Okay. If I have this as my array, 3, 0, 1. Okay. What is the only value that differs in these two arrays? It is this 2, right? So can I like, if I add all these values and subtract with these all values, I will get the answer, right? Okay. So what's my approach? First of all, I want to generate all values from 0, 1, 2, 3 up to n. Okay. And I should add them all. Just add it, add it, add it. So what is my value? It will be gonna be 6, right? 6. Now I'm going to add every value in the list. What is the value? 0 plus 3 plus 1, which is equal to what? 4. Now I'm going to minus it. 4 minus, sorry, 6 minus 4 is, which is equal to 2. So 2 is my answer. Can I understand this? Okay. What is the time constant space complexity? I can say my time complexity will be O of n because I'm taking only sum. Just traverse one time. What space? It is O of 1 because I haven't taken any array. I just took the sum. Like I'm going to traverse from 0 to 3 and take the sum of these values. That's it. I'm not changing to array. Okay. Now, another bonus approach is that we can also use bit manipulation. Okay. You may ask how we are going to use bit manipulation. Okay. I will explain it. See here 0, 1, 2, 3. And here also 3, 0, 1. Okay. Now, listen carefully. Listen carefully. This 0 repeated 2 times. If we combine these two. This 1 repeated 2 times. This 3 also repeated 2 times. This 2 only repeated only 1 time, right? So this could be my answer. So every element repeats what? Twice. But only one element is 1 time. So I can say if I take XOR of each and every elements into array and again XOR it, I will get this 2. You may ask how. Just wait for it. First of all, I just traverse to this entire 0 to 3 and I will take all numbers as XOR. So if I take XOR 0, XOR 1, XOR 2, XOR 3. So this is initially. Now I will take every elements in this with these elements. So XOR 3, XOR 0, XOR 1. So in XOR it has property. If it is two things are same, it will be 0, right? Okay. 0 and 0 will give 0. 3 and 3 gives 0. 1 and 1 gives 0. And everything are 0. Now remaining is 0 XOR 2 which is equal to 2. So 2 is my output. If you don't know about this Bitman version, I will give you the link in the description. Go and watch the Bitman version playlist. Okay, fine. Now, what is the time complexity and space complexity for this approach? I can say time complexity will be O of n and space complexity will be O of 1 because we are only using what? A single variable. So this and these two approaches are similar. Fine. Let us see the code. See here, this is the code. First of all, I'm just iterating to what? Whole length. Okay. Here I can also put like plus 1 also. Okay. Let us see the code. See here. For I in range of len of nums plus 1. Now, for j in range of len of nums. So I am just iterating from what? 0 to 3 and iterating to each and every element. I will take 0 first. Then I will see whether 0%. Now I will take 1. Then I see 1% like that. If it is present, I will break it. Okay. If this whole loop runs successfully, then I will return what? Can you understand it? If it is not present only, it runs successfully. Then I will return what? I. In C++ or Java, you may ask, you may put a flag variable here. Flag is equal to 1. And initially, the flag will be what? 0. Okay. Here, put a condition. If flag value turns out into 1, then only I want to return this. Okay. Let me submit it. Sorry, this will be 0. Because initially this value is 0, right? So we want to check whether it is 0. That means only what? This flag value didn't change. Let me submit it. Yes, it is submitted successfully. Now, going to the optimal approach. See here, first of all, I'm just sorting it out. Then I will check whether the previous element, okay, here I done another approach. Here I done like, I'm checking whether the current in this and that value is equal. In previous approach, what I done, here I done like 1 plus 1 plus 1 plus. But in code, I have used like, here, it is 0th index, first index, second index, third index, fourth index. If the index and the number differs, then the index would be my answer, right? This is the logic I used here. I is not equal to nums of I, then return I. Okay, if this loop executes successfully, then n will be my answer. If 3 is not present, this loop runs successfully, right? Okay, let me submit it. Yes, it is submitted successfully. Now, I will show you like 3 is equal to minus 1 initially, okay? Now, what should I do? If current value, okay, is equal to previous plus 1, then only the condition is true. Then I should use what? Not equal to previous plus 1. Then I should return what? That in this value. Can I understand this? Yes, in this value. Okay. Let me run it. What happened? One. Okay. Plus 1, I forgot. See here, this is the code I have told you in that approach. Okay. See here. First of all, nums dot sort of, then 3 is equal to minus 1. Then I am iterating to each and every element. Now, if nums of I is not equal to 3 plus 1, which means previous element should be 1 less than, right? If 2, next should be like 3, like that. Return 3 plus 1. If that is not the case, if we are 2, then 4. My 3 is 2, my current is 4, then 3 is missing, right? So I should return what? 3 plus 1. And each and I will increase my 3. Now, if that loop executes successfully, then I will return the length of this num. Let me submit it. Yes, it is submitted successfully. Now, coming to the next approach, see here, this is the array approach. I told you, right? Both are in linear time, space and time velocity. First of all, I am taking an array and declaring it as 0 for 0 to that length. Okay, that means 0 to, if 3 is a length, 3, 0, 1, 2, 3. All are declared as what? 0. Initially, it is initialized as 0 and added into each and every element, then making that each element's value as 1. And again, I am adding to the what? This array. I should iterate to this array, right? Wait a second. I can also iterate to this array or nums plus 1 also. This is also correct. Okay, I iterate and I will check whether there exists any value that equal to 0. If that exists 0, then I will return what? I. Let me submit it. Yes, it is submitted successfully. Now, going to the next solution, which is the what? That sum and taking that sum and minusing it. See here, first of all, I am traversing with the entire range. If the length is 3, I will traverse from 1, 0, 1, 2, 3. Okay, then I will take those sum in S. Now again, I will traverse to the entire array and I will minus those elements. And the remaining element will be my answer. That's it. Let me submit it. Yes, it is submitted successfully. Now, last approach is the Bitman version approach. See here, I am taking the range and iterating this I. Then I will take XOR of this. Then I will browse to the entire array and I will take the XOR on it. Duplicates will be removed and single number will be in yes. I will return that yes. Let me submit it. Yes, it is submitted successfully. Thank you.